So SCOUT is a new framework from the Earth Observation Directorate in the European Space Agency. Each SCOUT mission consists in three main constraints. The first one is the SCOUT mission needs to bring science and technology innovation. The second one is that it's a fast development approach. It's 3 years between kickoff and launch, and it's a low-cost mission below 30 million euros. These three constraints are made compatible with each other by using the new space paradigm, which consists essentially of two aspects. ESA gives a much more prominent role to industry and academia, and we use an agile approach to go for a fast-track development cycle. SCOUT 1, also known as CubeMap, is managed by GomSpace from Denmark and RAL from the UK. Hydrogen SS is entirely built by SSTL from the UK. SCOUT missions can also be used to fill specific scientific gaps without having to wait for larger missions to be launched. Both CubeMap and Hydrogen SS are due for launch in Q4 2024, which is 3 years after kickoff. So in a nutshell, SCOUT missions are literally scouts in the sense that they pave the way to more innovation, which can be reused on other bigger and larger missions. CubeMap aims at improving our understanding of the upper troposphere and stratosphere. It will measure a number of key radiatively gases like methane, like nitrous oxide, like carbon dioxide, like water vapor, and it will also measure aerosol. CubeMap will focus on tropical and subtropical latitudes, so latitudes between -40 up to +40 degrees. And this band of latitudes is of interest because there are many fast-growing cities in this band with their associated emissions. It's also an area with many volcanoes injecting a lot of dust into the atmosphere, and it's an area with a lot of biomass burning from tropical forests. Hydrogen SS uses the principle of GNSS reflectometry to provide observations related to the hydrological cycle. The hydrological cycle is, of course, a key aspect to sustain life on Earth, and Hydrogen SS will provide inputs to essential climate variables related to the hydrological cycle. Hydrogen SS uses a very cunning principle, which is to compare the reflected signals coming from GNSS satellites reflected by the Earth's surface, to compare these signals with the direct signals received from the same satellites. And by making the comparison, it is possible to derive important information related to above-ground biomass, related to ocean wind speeds, related to the freeze-thaw over permafrost, and also soil moisture elements, which all these elements are very important and are classified as essential climate variables. Hydrogen SS will complement other missions sensing soil moisture, like biomass or SMOS from ESA or SMAP from NASA.
The main instrument that CubeMap embark is IROS. It's a spectroradiometer based on laser heterodyne technology, which gives to the instrument characteristics very important, such as very low power consumption, lightweight, and very compact size. This is very important for us because this means that we can embark in a small and nano satellite, which means that we can launch several of these in a constellation fashion in order to cover a wider area and having much more measurement of the tropical and subtropical area. The main challenge of CubeMap relies on is sensing technique. In fact, we need to acquire the atmosphere signal illuminated by the sun from behind. This means that we need to follow the sun motion during the sunset and the sunrise, and we need to also to take into account that the image of the sun itself squeezes depending on the refraction of the atmosphere, and this is very difficult and implies that we need to have a very accurate pointing of the satellite. It's a little bit like William Tell that need to point the sun toward the atmosphere. Hydrogen SS embark a GNSS receiver which is able to receive the direct signal from our GNSS satellites such as Galileo and GPS, but also the reflected signal from the land. By comparing the direct and the reflected signal from the land, we are able to understand the characteristic of the land itself, and in particular the water content. And we will be able to measure environmental climate variables such as permafrost, water lens, biomass and soil moisture. HydrogenSS brings a lot of innovation, and in particular the fact that he acquires a dual polarization and dual frequency of the GNSS reflected signal from the ground is very innovative, but at the same time it is also the main challenge, because we do not really know all the characteristics of the signal that we are going to acquire. This means it's like diving in the dark. We do not really know what we are going to get, but it will be for sure exciting.
I do think the future of SCOUT is really bright. So far we have received an enormous interest from the science community, from industry, from academia. SCOUT offers a possibility to do innovative science in a reasonably short time frame with a reduced budget, which is far more easy to accommodate than much larger missions. So I do believe the future of SCOUT is bright.